Hi everyone, my name is Reiven Nozaleda. Me and my partner will be explaining a simple C# program that converts a hexadecimal number into different number systems, specifically binary, octal, and decimal. The first part of the program is called initialization, where char retry is equal to y. This declares a character variable retry and initializes it with y. It controls whether the program should repeat or stop after each conversion. On the second part, while loop, as we can see, while retry is exactly equal to small letter y, or retry is exactly equal to capital letter Y. The program will keep looping as long as retry is exactly equal to small letter y or capital letter Y. This allows the user to perform multiple conversions without restarting the program. The third part, display the conversion menu. So, these lines print a menu of conversion types. At the program, console.writeLine, choose a type of conversion. Dito na papasok yung menu natin, which is console.writeLine, choice A, hexadecimal to binary, choice B, hexadecimal to octal, choice C, hexadecimal to decimal. Then after that, console.write, enter choice. This part, the user is asked to enter a letter A, B, or C. After that, char choice is equal to char.parse, console.readLine. So, console.readLine reads input as a string, and char parse converts it to a single character or choice. At the fourth part of the program, as we can see, console.write, enter hexadecimal number. The user types a hexadecimal number like 1A, FF, or 3E8. The next part of the code is string hex is equal to console.readLine. So, why string? It is stored as string in the variable hex because the user's input from the console.readLine is always read as text. Hexadecimal numbers includes letters A to F, which cannot be handled directly as numeric types. So, keeping it as string allows the program to validate and process it easily before converting it to a number. The fifth part of the program checks if the input is a valid hexadecimal. The first part of the code is bool is valid equal to true for each char, ch, or character in hex. It is a validation loop that checks each character in the input. The next part of the code is if not ch is greater or equal to 0 and ch is less than or equal to 9, or ch is greater or equal to capital letter A and ch is less than or equal to capital letter F, or ch is greater or equal to small letter a and ch is less than or equal to small letter f. So, the valid hexadecimal digits are 0 to 9, capital letter A to F, and small letter a to F. Then the last part of the code is valid equal to false, then break. If any character is outside these ranges, it sets is valid to false and breaks the loop early. So, the sixth part of the program, handle invalid input. The code starts with if not is valid. console.writeLine invalid hexadecimal number. So this explains if the input isn't valid, it prints an error message and skips the conversion. So next part is convert hexadecimal to other number system. If valid, the program converts the number using this code. Int_dec is equal to convert.toInt32 hex 16. So convert.int32 hex 16 converts the hexadecimal string to an integer or decimal. The 16 means the original number is in base 16 or hexadecimal. Then, a switch statement decides what kind of conversion to do.
So the program starts by asking user to enter a decimal number. So after the user inputs a number, it displays a short menu where the user can choose how they want the number to be displayed. So if the user enters A or small letter A, the program converts the decimal number into a binary base 2 using convert.toString decimal 2 method and then shows the result. So when the user chooses B or small b, the program performs a conversion from a decimal number to an octal number, which is also known as base 8. So the octal numbering system uses the digits 0 to 7. In this case, the program first converts the hexadecimal input into its decimal equivalent, and then it uses the convert.toString decimal 8. It is a method to change the decimal value into an octal representation. The number 8 inside the parenthesis indicates that the target base is octal. It is to allows the program to easily display the correct octal value of the user's hexadecimal input. So when the user selects C or small c, the program simply displays the decimal value of the hexadecimal input. So there is no need for further conversion because the program already converted the hexadecimal number to a decimal value earlier using convert.toInt32 hex 16. So this option just shows the result directly, allowing the user to see what the hexadecimal number equals in base 10. It is the standard number system we use every day. So if the user enters any character or letter other than A, B, or C, the program executes the default case. So this is a built-in safety feature in the switch statement that handles invalid inputs. So when this happens, the program displays an error message saying invalid input. It is to inform the user that their choice does not match any of the available options. So this prevents the program from crashing and helps guide the user to enter the correct input next time. So the method convert.toString decimal base plays an important role in this program. It is to allows the program to convert a decimal number into another number system simply by changing the base value. So for example, if the base is 2, the result will be in binary form. And if the base is 8, the result will be in octal form. So this makes the conversion process easy and efficient without needing to write long manual calculations. And after the conversion is complete, the program asks the user if they want to try again by displaying message try again, Y, or N. So if the user types Y or small y's, the program repeats the entry process by restarting the loop, showing the conversion menu again, and waiting for new input. So it is to allows the user to perform multiple conversions without restarting the program. And before starting each new round, the program uses console.clear to clear the console screen. This makes the interface look cleaner and easier to read by removing the text from the previous conversion. So, the user can focus on the new menu and input. So, at the end of the program, the statement console.readKey is used. So, this line tells the program to wait for the user to press end key before it closes. So, it is a common technique used in console application to prevent the window from closing immediately after displaying the result. And by waiting for a key press, the user has enough time to review the output before the program exits completely.
Now let's try the program. The console asks the user to choose a type of conversion. Since I want to convert hexadecimal to binary, I choose A. Then the console asks the user to enter a hexadecimal number. So after entering the number, the console displays the conversion. It then asks if you want to try again. Since I want to convert hexadecimal to octal next, I enter B, then input 1B. The console shows the result and again asks if you want to try again. Now let's try converting hexadecimal to decimal. I enter C, then input 1B, and the console displays the answer. Since we don't want to try again, we enter N or no, and the program closes.